Look up into the night sky. What you see are countless points of light, each one a star. A star is a giant glowing ball of extremely hot gas, mostly hydrogen and helium. Its light and heat are produced by a powerful process deep within its core. Like living things, stars have a life cycle. They are born, they live through a long middle age, and eventually they die. This essay is a roadmap of that incredible journey, from a star's birth in a cosmic cloud to its final, often spectacular end. Understanding this life cycle is not just about astronomy. It's about understanding where we and everything around us came from. The story of every star begins in the vast, cold, and dark spaces between other stars. Here, immense clouds of gas and dust drift through the galaxy. These are called nebulae. For reasons we are still exploring, perhaps the shock wave from a nearby exploding star, a section of this cloud begins to collapse. Gravity, the universal force of attraction, takes over. It pulls the particles of gas and dust closer and closer together, causing the cloud to fragment into smaller, denser clumps. Each one of these clumps has the potential to become a new star. As a clump of gas and dust continues to shrink under its own gravity, it starts to spin faster and faster, much like an ice skater pulling in their arms. The material at the center gets incredibly compressed, and this compression causes it to heat up dramatically. This hot, dense, and glowing core is known as a protostar. It is the embryonic stage of a star, not yet shining from the process of nuclear fusion, but glowing brightly from the heat generated by its gravitational collapse. It continues to gather more and more mass from the surrounding cloud, growing hotter and denser with each passing millennium. This process of gathering mass cannot go on forever. Eventually, the temperature and pressure at the core of the protostar reach a critical point, about 15 million degrees Celsius. At this mind-boggling temperature, a new process ignites nuclear fusion. This is the moment a true star is born. Once nuclear fusion begins, the star enters a long and stable period known as the main sequence. This is the adulthood of a star's life, where stars spend about 90% of their existence. Our own sun is currently a main sequence star. During this phase, the star is in a state of equilibrium outward push of energy from fusion in its core, perfectly counteracting the inward crush of its own gravity. The star will steadily fuse hydrogen into helium, shining with a consistent brightness color, for billions of years a reliable source of light and energy for any planets that may orbit it. The characteristics of a main sequence star are color, temperature, brightness, determined almost entirely by its mass. The more mass a star has, the more gravity it possesses, resulting in higher pressure and temperature in its core. This increased pressure causes fusion to happen much faster. Consequently, massive stars are incredibly hot. Every star, no matter its size, will eventually run out of the hydrogen fuel in its core that has sustained it for billions of years. When this happens to a low-mass star like our Sun, its life enters a new and dramatic phase. Without the outward pressure from hydrogen fusion to support the core, gravity once again takes over and begins to crush it. This compression causes the core to heat up immensely. While the core shrinks, the new heat forces the outer layers to expand like a giant hot air balloon. The expanding outer layers cool, shifting the star's light from yellow-white to deep red. The star has become a red giant. When our Sun reaches this stage in about 5 billion years, it could swell to engulf the orbits of Mercury, Venus, possibly even Earth. Despite a cooler surface, its size makes it far more luminous than on the main sequence. The star burns hydrogen in a shell around a helium-filled core. Eventually, the core becomes hot and dense enough to ignite a new fusion phase, converting helium into carbon and oxygen. That fusion gives a temporary energy boost, but helium is consumed far faster than hydrogen. After helium runs out, the star's life winds down. It becomes unstable, and the outer layers drift into space. expanding shells of glowing gas, lit by the hot core, form a planetary nebula. Left at the center is the dead core, a white dwarf.